Welcome to another episode of our project Medical Enlightenment. Please subscribe for more videos. We talk about medical videos. So today I'm going to talk with you about a very basic conception definition in medical fields. There are agonists, antagonists, passive agonists, as well as inverse agonists. Although they are very basic, they usually confuse people and if you get it wrong, it is very serious for your study as well as for your career. So I'm going to clarify it for you today and give you some example. Remember that this our channel is about medical field, so sometimes we use some names of agents of drugs that people in other fields may be confused with them, but don't worry, they're just the name. So first, let me talk about the agonist. So what is agonist? Agonist is defined as molecule that mimics the activities of endogenous ligand. Yes, so I have endogenous ligand. So endogenous ligand are molecules inside the body that trigger the physiological activities for you to function every day, to keep your body alive, to keep everything well. So let's have an example. Let me take an example of endogenous ligand here. I have acetylcholine here. Acetylcholine. Yeah, acetylcholine is a kind of neurotransmitter that will bind to the receptor, nicotinic receptor. So you have nicotinic receptor. It will bind to it. Let me draw it here. So if we have a membrane here, yeah. So if I have a cell membrane here, and usually then the receptor they are embedded in the membrane. So for example, yeah. So this is the receptor. So physiologically, acetylcholine after being released from the neuron, they will bind here. So you can think it's something like this is a key and this is a locker. So if a key binds to a locker, it will unlock the locker and it will trigger the response inside the cell. So this is an endogenous ligand. And so what is an agonist? Agonist is another molecule, usually the molecule from outside the body, maybe a drug or other agents, and that will enter your body and will trigger a response that similar to your endogenous ligand. Ligand or ligand, they are both well because I live in different countries and they use different pronunciations. I prefer ligand here. So let me have an example of an agonist here. I have succinylcholine. Yeah, succinylcholine. This is a type of nicotinic agonist. So when it enters the bodies, it travels in the bloodstream and it finds its specific receptor and it will bind here, and it will also trigger the response. It activates the receptor, and then this complex glucose will signal further inside the cells to cause the similar activities. So this is antagonist. So let's move to antagonist. So okay, let me scroll down here. Okay, if you have an antagonist, Antagonist, antagonist here. So an antagonist are defined as molecules that block the activities of agonists. So this it can be endogenous agonist or endogenous ligand or agonist from outside the body, for example drugs. Okay, so let me have an example here. So if I have an cell membrane here, another cell membrane here, and I have an ion channels here. Yeah, let me have an ion channel. Yeah, I have an ion channel here. Let's have an calcium channel. Calcium channel. So if you have an endogenous ligand, it binds to the receptor on this channel. It will cause the channel to open up, for example. So this is a closed state. If if the agonist binds to the channel, the binding site on the channel, it will cause the channel to open up. Yeah, this guy to open, to flip up, and then the calcium can come in and it will trigger further events intracellularly. So what does an antagonist do? So you an antagonist may have a same side, a similar side to an agonist, and basically they will bind to the binding side. For example, in this side, the binding side for an agonist here. And so if your agonist come here, it cannot bind here because the antagonist has already blocked its way, so it cannot cause the activity. Remember that. Please bear in mind that the antagonist does not cause the opposite effects to an agonist. They basically block the activities of an agonist. So because for example the agonist cause contraction, and so if an antagonist block the binding side of an agonist, so the muscle will be relaxed, and you may think that they cause opposite effects. That this is not true, because the antagonist does not have any intrinsic activities. They are defined as molecules that do not have any intrinsic activities. They just block the activity of agonist. Okay, so this is an antagonist. So let's move to another. So here we have partial agonist. Yeah, I guess you can know. I know. I guess you know what are they, because they are agonists and they just have partial, not full agonist. So the partial agonists are agonists that cause the activities, the pathway similar, the pathway of activity similar to the endogenous ligand, endogenous agonist, but their efficacy, or you can use potency may not as the full agonist. For example, the full agonist, it may cause 100%, and the partial agonist, they may just go, for example, from 10 to 99%. So they may be partial agonist. This is very easy to understand it. Yeah, they bind to the same side of the agonist. They trigger the similar pathway of mechanism of action, but eventually they don't have enough magnitude of efficacy when compared to the full agonist. And the final definition here we have an inverse agonist. Yeah, this is a bit more complicated. So what is an inverse agonist? Inverse agonist is defined as a molecule that stabilize the constitutive activity of a receptor. So what is the constitutive activity? Yeah, we have constitutivity. The constitutive activity is an activity that normally, when there are no agonists bind to a receptor, it still triggers some events intracellularly. You should understand, you should bear in mind that when even don't have any endogenous ligand bind to a receptor, the body, your cells still have activities. It may be triggered by the receptors, so something like that. But your cells, your body don't stay at one place. They don't sleep. They don't sleep, and they don't just wait for the agonist to come and bind to the receptor, and then they will awake and they will be activated. And trigger some response. It's not like that. Normally they still have constitutive activity. So that is the constitutive activity, and usually the constitutive activity is opposite to the response from agonist. So for example, normally your cell relax when an agonist. Your muscle cell is relaxed. They are at relaxing state. But when an agonist binds to the receptor and a series of events, a chain reaction happens, take place, and then the muscle will contract. So these two activities are opposite, maybe like that. And then you have an inverse agonist. Inverse agonist will stabilize the constitutive activity. So they are still agonists. They do not block any agonist, but they just stabilize the constitutive activity of agonist. So they will have the opposite effect to an agonist. So that is an inverse agonist. So if I have a graph here, yeah, with two axes. Yeah, here I have the response. Yeah. So here I have the time axis, and I will use different color for this. So if you have, so you have 0. Yeah, so we have 0 here. For example, here you have minus 50% response, you have 50% here, you have 100% here. So first, if you have a full agonist, it will be something like this. Yeah, because they will call, so this is a full agonist, so they will call 100% response. And then if you have a partial agonist, and partial agonist will cause the response run from this range to this range, so maybe 50%, 60% here. Yeah, and then if you have an antagonist block the activities of an agonist. So antagonist, it is, yeah, the flat line. They are the flat line. So this is the antagonist. And finally, if you have an inverse agonist will call the opposite effect to your agonist. So this is your inverse agonist. So let's have a look again. So here we have agonist. They mimic the activity of endogenous ligand or ligand. Antagonist, they block the activity of agonist. They block activity of agonist because they usually bind to the binding site of agonist, so the agonist cannot bind to that site anymore, and so they cannot cause any activity. But bear in mind that the antagonists do not trigger any response to your cells. Okay, and here we have the partial agonist. A partial agonist will bind to the same binding site of your agonist, but their percentage, their proportion of efficacy is not 100% of your full agonist, because there may be sometimes their binding affinity may not as well as the agonist, or maybe they fully bind to the binding site, but they do not have enough efficacy potency when compared to the agonist. And here we have the inverse agonist. The inverse agonists are something that stabilize the receptor at their basal state. Yeah, because in basal state the receptor still trigger some constitutive activity to your cells. So the inverse agonist, and then the agonist bind to the receptor, and they will cause the opposite effect. But when we have an inverse agonist, they will stabilize the activities, so they are opposite to the agonist. So this is inverse agonist. So I hope I can clarify everything for you. Please